Hello, everyone. Thank you so much for joining our session on how to get started with deep learning on PyTorch. I'm super excited to take you on a short journey here. I'm Joe Svizak. I'm the product lead for PyTorch at Facebook. I'm joined by my colleague, Alexander, who will also give you a demo on AI Habitat, a 3D navigation and interactive environment for virtual robots. So a bit of the agenda for today. We'll talk about what PyTorch is and give you a flavor for the project itself. Then we're going to dive into some code and help you get started. We'll also give you an idea of what it's like to train a neural network model and solve a task. Then I'm going to hand it over to Alexander, who will walk through the demo of Habitat. And then we'll finish up with a few pointers on how to get started, get your hands further dirty, and learn more. So without further ado, let's get started. So what is PyTorch? Well, PyTorch is a machine learning library for training neural network models. But it helps to start with what the mission is first and what we're trying to achieve. In the end, PyTorch is about accelerating cutting-edge AI research to production. There's so much happening today across natural language processing, robotics, computer vision, and all of that can have a huge impact on the world. We want to create a flywheel. We want to bring that cutting-edge research and bring that research into production so we can have product impact. That's our North Star. So how do we invest to achieve this? Well, we start by enabling cutting-edge research in the first place. This includes things like developing front-end APIs and new modeling paradigms. If anyone is familiar with GPT-3 or newer transformer models, we're finding that these actually can propagate to other parts of the field and turn into new products. We also need a comprehensive set of domain libraries. There are a number of subfields in AI, like computer vision, language modeling and translation, as well as reinforcement learning that are very specialized. And these different areas require layers, models, data sets, and primitives that are unique to them. So in order to innovate, we need to basically provide a number of different domain libraries or work with the community to develop them. And then switching over into production. So again, PyTorch is all about accelerating research to production. So how do we enable the production side of that? So first and foremost, performance is all about hardware acceleration. We need to be able to support backend accelerators. We also need to be able to support and train large-scale models and do it quickly. This is really the lifeblood of innovation in AI, being able to iterate quickly, and especially on the latest hardware. We're also investing in the ability to compile to these different architectures and be able to generate code for them. So the hardware architecture world is so diverse today, whether it's on your device, like in the new MacBook Pro, or on a server like NVIDIA GPUs or other accelerators that a number of companies are developing. We want to enable all that hardware acceleration and drive performance on both ends. And then there's model scale. So some of the biggest breakthroughs these days in tasks like computer vision and language modeling are coming through large, complex models that are in the trillions or even hundreds of trillions of parameters. So we want to enable big, complex models trained at scale that can push the state of the art. But of course, that's only the training side. We also need to enable the inference side as well and be able to deploy them for large-scale inference. And then lastly, on-device. On-device is so important for a number of reasons. It improves latency, user experience. Basically, it allows you to run your PyTorch on a mobile device, IoT device, or even on a set of AR glasses. On-device is also important for privacy and privacy by design. It allows you to run models locally on a device instead of on the server. So no data and no model actually leaves the device itself. Some of the areas we're investing in for on-device include having a unified runtime. So we want this to be all PyTorch. We also want to be able to support areas like model optimization. So these environments like on-device actually are resource constrained. So we need to be able to support optimization techniques such as quantization, pruning, or sparsity. Lastly, we want this to be an end-to-end workflow. We want you to be able to start with your data, train your model, and deploy to these devices, all in a common workflow. Basically, we're trying to optimize for developer efficiency. So all that said, it takes a village. It actually takes a community to invest in all of these areas. And this community is one of the biggest strengths of PyTorch. If you start with the open source PyTorch community, we have over 1,800 contributors, over 40,000 users on discussion forums, answering each other's questions, helping each other out. And all that results in over 71,000 downstream GitHub projects depending on PyTorch. This community is enormous. And it's amazing to see how they collaborate, build on each other's work. and generally push the field forward. And then if you look at research, one of the ways to gauge the research community adoption is through papers published on arXiv. arXiv is this repository for academic and technical papers. If you look at some of the numbers here, in the recent month, we had over 1,100 papers mentioning PyTorch, which is over 64% year-over-year growth. It's pretty incredible, actually. Also, if you're familiar with paperswithcode.com, they have a great trends metric. And they actually have a metric that we actually have over 60% of the papers of code in the ML space that use PyTorch. So overall, the research space is very strong with PyTorch. The PyTorch community is also strong in production. So that whole flywheel of research and production we talked about, whether it's Facebook using research to production, or Microsoft, or Tesla, or Disney, there's a really broad community of production users taking advantage of all the goodness coming from research and bringing it into product impact. Another way the community comes together is through libraries. If you need a library in PyTorch, there's probably one available. Whether it's engineering productivity, libraries like FastAI, which has a fantastic global community around it, or PyTorch Lightning, or specific in-domain libraries like Monai for medical imaging, as well as libraries like Hugging Face for natural language processing. There's also a great community around responsible AI-centered tools, for example, like privacy-preserving machine learning, and a library called Opacus for differential privacy is one. This community is really broad and growing every day. If you look at the ecosystem and tools and users, there's actually a lot of interesting use cases that are resulting. So starting with autonomous driving is a really interesting space that spans research and production. A lot of companies within the space are using PyTorch. These include Tesla, Lyft, Uber, Aurora, and Cruise. This has been really incredible, and we've actually co-engineered a lot of PyTorch with these partners. Another use case is Wadhwani AI. They're a nonprofit dedicated to applying AI to solve problems for social good. One of the challenges they're trying to tackle is preventing pest attacks on cotton, which is a major worldwide crop. Wadhwani AI has developed models in PyTorch that identify pests in images taken by farmers in their fields. And these models are actually specialized to work in areas with limited network coverage. Their solution has helped nearly 15,000 farmers across India. So with that said, let's get our hands dirty and pull up our Jupyter notebook and dive into some code. Okay, awesome. We have our Colab notebook set up, and you can see here, we're going to start with importing our needed packages. We'll start loading our data. We'll define our neural network architecture. We'll do some setup of hyperparameters. These are parameters needed to help train our model. We'll also set up TensorBoard, which is a great tool for visualizing not only our neural network, but also things like data or how our model's training. We will train our network. We're just going to train it on one epoch, so one iteration over the data because of time constraints. We'll then visualize how we're doing in TensorBoard, and we'll actually finish up with doing some new predictions. So let's get started. So we'll start with FashionMNIST. So for those not familiar with FashionMNIST, it is a data set of thousands of images that are 28 by 28 grayscale of different articles of clothing. And it's really kind of a fun project and fun way to learn neural networks. We have to start with importing our packages. And so we have a number of different things that we need to train our neural net. We're going to start with some of our visualizing and charting tools. So matplotlib. We also have NumPy, which is a data manipulation and scientific computing package. We, of course, have our native Torch packages, Torch Vision. And then we have a bunch of sub-modules in the case of Torch NN and functional, as well as Torch Optim. These will help us train and define our neural network. From there, we actually load our data. So we start with transforming. So we want to convert everything to tensors. That's the common language of a neural network. We want to normalize our data so that PyTorch can consume it. And we then take that normalized data and convert it to a train set and a test set. So this is what you want to train on, and then you want to hold out data to then generalize your model to new problems. So you want to have a holdout set. From there, we actually will define a train loader and a test loader. This is how we actually batch our data up so we can actually train on it efficiently. We will define a number of classes. Remember, we're doing FashionMNIST here, so we're talking t-shirts and trousers and ankle boots and other fun stuff. We'll also define a quick function that allows us to visualize that data. From there, we actually can grab some of that data and just see what it looks like. And so you can see here, we've grabbed a batch of that data. And in this case, 4 images is our batch size. And you can see it's a shoe and there's a pullover and different types of shirts. So we kind of have some data to work with, which is great. So now we need to define our neural network. In this case, we're actually using a fairly basic multi-layer perceptron, also commonly known as a fully connected neural network. And so in this case, we are creating a class. We're calling it classifier, and we're subclassing that class on NN module, which allows us to pull these different types of layers. In this case, we're using a lot of NN linear layers. From there, we actually will define a forward method. And in this case, what this allows us to do is actually interleave these different nonlinear functions and create the forward pass of our network. And we'll finish with a softmax, which outputs basically a prediction based on those 10 different categories that we've actually defined here. From there, we're actually setting up our loss function, our optimizer, and a few hyperparameters. In this case, our criterion, or how well our network is doing, we're using the negative log likelihood loss criterion. We're actually going to be using the stochastic gradient descent optimizer with a parameter, a hyperparameter called learning rate, which we're setting to 0.01. We also need to set up some logging so that TensorBoard can actually take the data from our training and actually give us some nice graphs and actually show us what our neural network actually looks like. And setting this up in Jupyter is super handy. From there, we actually are defining our training loop. So when you train a neural network model, what you'll do is actually take a forward pass, a backwards pass, you'll do an update, record your loss, and you'll do this over and over and over until you've actually converged or you've trained to the desired number of epochs. And an epoch is really full iteration over the data set. So from there, we actually have TensorBoard up, you can see, and we have a few different tabs that we can play with here. And in this case, what we're doing is actually visualizing our epochs or the training iterations and what our loss is. So basically our loss is how well our network is doing. We can actually also look at the graph itself. And so you can see we've defined this classifier class. And you can actually dive into that, see the different layers underneath, and has a weight and a bias. So we know we have a neural network that's well connected. And this is a great way to debug it. So from there, we actually can take our neural network and actually do some predictions. So I just created this quick function called viewClassify. This creates a nice little handy visualization of our image as well as how well our model is actually performing. As you can see, we have all the 10 different classes that we've defined previously, and we have some labels and things on our X and Y axes. And so you can see here, we're actually doing some new predictions. So on the left here, we have a pullover. That looks like a pullover. And you can see our network is actually predicting that it's a pullover. So it's very confident that that's a pullover. And I can actually change this and run another prediction. And you can see in this case, it has a pair of trousers. It's also very confident that those are trousers. So our network learned a lot, even though we only did one epoch, which is really cool. So what's next? You go to PyTorch.org. There's lots of tutorials, blogs, and more educational materials. And now I'm going to hand it over to Alexander.
Hi, everyone. My name is Alexander Maximus, and I'm a research engineer at Facebook AI. I'm here to show you AI Habitat, a 3D visual training environment for robots that build on top of PyTorch. AI Habitat applied deep learning to physical world. It takes robots hundreds of thousands of attempts to master one skill. So training a real robot is time-consuming and expensive. We created AI Habitat to solve this problem, allowing robots to train in virtual 3D interactive environments. Robots that train in Habitat can reach an equivalent of 80 years of human experience. So it's much faster and more efficient way to train them. We just released a second version of Habitat called Habitat 2.0. So the demo today will showcase some of the new features in that release, like interactive scenes and articulated robots. Habitat is open sourced under the MIT license. There is a lot of tasks that virtual robots can learn to do in Habitat. For example, robots can follow instructions, like leave the bedroom and stop in front of the window. Navigate a house and answer questions like, where is my laptop? Rearrange different objects. For example, robots can stock the fridge. Or my favorite one, clean a room. I will show you one example in depth. Here is a demo of the model we trained with PyTorch to set up the table for dinner. The model receives rewards for moving objects closer to their desired position. As it gets more rewards, it repeats the correct behavior. This type of training is great because it's generalizable. The robot can complete the task in other kinds of kitchens too. There is a lot of tasks robots can do in Habitat. If you are interested to try Habitat for yourself or learn reinforcement learning, check out our collab tutorial. Back to you, Joe.
Okay, thanks so much, Alexander. Great demo. So now that you know more about PyTorch and how to use it, I wanted to show you a few quick, easy ways to get started. First, check out the Learn the Basics tutorial on pytorch.org. This will introduce you to a complete ML workflow implemented in PyTorch. And finally, check out our website, pytorch.org. Follow us on social media and join our PyTorch community on GitHub. You'll find a lot of brilliant people in our community who are publishing research, contributing code, or they're just to help users solve problems. Thank you for joining our PyTorch session today. We hope you learned something new and feel inspired to join this amazing PyTorch community. Enjoy the rest of F8 Refresh. Cheers.